Example number 2, to derive the formula for time period of simple pendulum. There are 4 parameters in the pendulum, and these 4 parameters: mass of the pendulum, length of the pendulum, and theta and value of g. So there are 4 parameters. So time period, according to figure, we can estimate that time period directly proportional to length, mass, theta and g, acceleration due to gravity. Then this is equal to constant to length m, theta and g. So we write all these quantities in terms of their dimension of time period t. This is also equal to m0 l0 t1. This is dimension of time period, dimension of length, dimension of mass, and dimension of angle theta. Because S is equal to r theta, theta is equal to S over r. S is the distance which is taken in meters and r is the radius, this is taken in meter. So both have same dimensions, length and length inverse. So, and dimension of acceleration due to gravity, acceleration due to gravity is L t minus 2, because acceleration, unit of acceleration is meter second minus 2. So meter for length and second minus 2. So these are the dimension of all these parameters. So equation 1 can be written as, equation 1 can be written as m0 l0 t1, and right hand side constant power a, mass power b, theta power c, and g, acceleration due to gravity, units meters per second, and the dimension of g is L t minus 2 have power d. So we can write this is equal to m0 l0 t1, left hand side is constant, length there are 3 but 4 values of length: a plus c minus c or plus d. Then a plus c minus c और l d सबको हमने इकट्ठा कर दिया. m is पावर b और t माइनस 2d. t की पावर है माइनस 2d. Comparing the power, m0 mb b is equal to 0, length 0, or either length has power a plus c, a plus d can be written as this is a plus d, because these will be cancelled and there is only a plus d. So we can write that a plus d is equal to 0 and a is equal to minus d, and last t power 1 is equal to t power 2d minus 2d. So minus 2d is equal to 1, then d is equal to minus 1 by 2, and a is equal to plus 1 by 2 हो जाएगा, माइनस d है तो माइनस इंटू माइनस प्लस हो जाएगा, and b is equal to 0. Theta has no contributions. In according to this equations, theta has the power c and has a dimension L minus 1, so that is 0. So this is meaningless. Independent, we can say that this is independent of the angle theta, may be small, may be large. So now we put these values in this equation number 1. B is 0, number 1, B is 0 for the mass, and D is equal to 1 by 2 minus 1 by 2 power है g की, और a is equal to plus 1 by 2 is for the length. So equation 1 becomes, putting the value of the powers, equation 1 becomes t is equal to constant L, a has 1 by 2, m 0, theta 0, and value of g is minus 1 by 2, d is minus 1 by 2. So this is this can be written as constant L 1 by 2, g 1 by 2 minus m0 theta 0, meaningless, and this is constant L upon g under root. Since dimension analysis cannot explain the values of constant, or the numerical values cannot derive the values of the constant, so this is the drawback of the dimension analysis. Actually this here is 2 pi, but we can't write, this is the final formula for time period of simple pendulum, which explains that time period of simple pendulum is directly proportional to the square root of the length and inversely proportional to the value of g acceleration due to square root of the acceleration due to gravity. And this constant is 2 pi. Physically I know it that this constant is 2 pi, but here dimension analysis cannot derive the values, that's why we write it as it is. So this is very good example. There are number of examples we can derive the formula. There are some least other points, and we call it limitation of dimension analysis. Limitation of dimension analysis. We write it down. Number 1, it does not distinguish between the physical quantities. Number 1, it does not distinguish between the physical quantities having same dimension. For example, work, energy and torque, all these have same dimension. All these have same dimension. So we can't differentiate by the concept of dimension analysis. Point number 2. It cannot be used to derive formula. It cannot be used to derive the formula containing trigonometric function, exponential function, and logarithmic function. Point number 3. It cannot be determined the dimensional constant. It cannot determine the dimensionless constant. Like pi is dimensional constant, and this is there in a simple pendulum, but dimension analysis don't determines this constant pi. And number 4, it does not prove that equation is physically correct. It does not prove that equation, it does not prove that the equation is physically correct, that the equation is physically correct. Equation is physically correct even if it is dimensionally correct. Simple pendulum, T is equal to constant L upon G, this is dimensionally correct, but physically there must be 2 pi, then that will be correct equations. So it does not prove that the equation is physically correct even if its dimension is constant. However, determining a dimensionally wrong equation, dimensionally wrong equation will be physically wrong. Always मीन जो इक्वेशन डायमेंशनली रॉन्ग है तो वो फिजिकली भी रॉन्ग है, लेकिन जो इक्वेशन डायमेंशनली करेक्ट है वी आर नॉट डेफिनेट कि वो फिजिकली भी करेक्ट होगी, हो भी सकती है और नहीं भी, हो भी सकती है और नहीं भी, लेकिन जो रॉन्ग है वो फिजिकली भी, जो डायमेंशनली रॉन्ग है वो फिजिकली भी रॉन्ग है.